Okay, after this video and the one following it, you should be able to review multiplying binomials. We did that earlier this year. And then in the second video, we're going to look at factoring quadratics. So basically, we're going to be factoring trinomials into binomials. And it's essentially the reverse of multiplication. Okay, so let's review what we learned earlier this year. So if we were asked to multiply these two binomials, bi meaning two, right? Two terms, binomial, binomial. What we originally learned about the box method, or an area model, if you want to call it that. So we have x plus 5, and we have x minus 2. And we need to find the product of these dimensions, x times x squared, 5 times x times -2, -2 times -5, and then we combine like terms. X squared, these guys are like terms, plus 3x minus 10. Okay, then we looked at another method called the FOIL method. FOIL stands for first, outer, inner, last. So we multiply the first terms to one another, x squared. The outers, x times -2x. The inners, 5 times x. And then the lasts, 5 times -2. And what you'll notice is you end up with the exact same terms, right? When these terms match these terms. Combine like terms, and you end up with the same answer, okay? You can use either method. All right, so let's take a look at a couple other examples. You should pause here maybe and copy these down. So I'm going to go ahead and use the FOIL method because that typically becomes the faster method. So we'll take the firsts, the outers, the inners, and the lasts. And we combine like terms. Right, -2 and 9 gives us 7. Okay, again, we'll come down here, we'll use FOIL. Firsts, the outers, the inners, the lasts. Now an interesting thing happens here. -5x and a positive 5x. This creates a 0. So I have x squared minus 25. Okay, that's a unique situation that's called the difference of squares. Okay, x squared and -25, these are both perfect squares. When you have two binomials who have, these are the same, but these are opposites, the middle term will go away. Okay. All right, let's take a look at this one. This caused us a lot of trouble earlier this year. X plus 7 squared. Well, that's x plus 7 times x plus 7. Firsts, outers, inners, lasts. So I have x squared plus 14x plus 49. Okay, now let's think about if you had done this instead. You said, oh, well, I could just square this, x squared and 7 squared. No, can't do that. You're missing the middle term, the positive 14x. Okay, this is not correct. You cannot distribute an exponent over addition or subtraction. No, 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 no. All right, let's take a look down here. This is not 4x squared plus 9. You're going to forget the middle term. We have to take 2x minus 3, 2x minus 3. Firsts, 2 times 2, x times x is 4x squared. Outer, minus 6x. Inner, minus 6x. Last, plus 9. 4x squared minus 12x plus 9. Oops, sorry, 4x squared minus 12x plus 9. So there is kind of a little bit of a a rule to that. If you have a plus b and it's squared, it becomes a squared and b squared at the end, just like if you had wanted to distribute it. But in the middle, it's a times b doubled. If it was a minus b squared, it's a squared, and we have a b squared at the end. But in the middle, it's negative 2ab. A times b doubled. If you look at my rule, 2 times negative 3 is negative 6, doubled. Take a look at here. 7 times x, doubled, 14x. Okay, quick little shortcut if you remember that. That's it for this video.